Okay, so today we're going to dive into this really fascinating paper that's all about making satellites safer. And it does it by borrowing an idea from nature. We're going to break down how engineers are using what's called swarm intelligence to stop catastrophic failures before they even happen, way up in space. All right, let's start our story millions of miles from Earth. Up there, a single tiny component can be the only thing standing between a successful mission and $1 billion failure. I mean, this is the world of spacecraft attitude control, and let me tell you, the stakes could not be higher. So, you have to wonder, right? How do these incredible multi-million-dollar machines stay perfectly pointed in the absolute emptiness of space? How do they aim their cameras, their antennas, their solar panels with just pinpoint accuracy? Well, the answer is this amazing little device called a reaction wheel. The easiest way to think of it is like a very, very precise spinning top. It all comes down to a basic law of physics, conservation of angular momentum. When that little wheel spins one way, the whole satellite rotates in the opposite direction. It's a beautifully simple and super effective system for controlling exactly where the satellite is looking. But, and this is a big but, here's the catch. If this absolutely critical part starts to fail, you can't just send out a mechanic. And as the paper points out, just packing a spare, what they call hardware redundancy, usually isn't an option. There's just not enough space or power, especially on these newer, smaller satellites. This is where the engineers get really, really clever. Instead of just waiting for something to break, they've built a system that can actually predict a failure long before it becomes a catastrophe. It's kind of like having a digital detective on board, 24/7, just monitoring the health of the system. So what they do is create something called a digital twin. Basically, it's a perfect mathematical model of the reaction wheel's physics, and it runs on the satellite's computer right alongside the actual physical hardware that's spinning away. There's an algorithm that is constantly, nonstop, comparing the live data from the real wheel, its speed, how much current it's drawing, with the predictions coming from its perfect digital counterpart. It's like a continuous real-time health checkup. Any difference, any little deviation at all between what the real wheel is doing and what the perfect model says it should be doing, that difference is called a residual. And that residual, well, that's the very first clue our digital detective gets that something might be starting to go wrong. But, and this is the whole point of the paper, this digital detective has a pretty significant weakness. There's a blind spot in the algorithm, at its heart, that could literally put the entire mission at risk. The algorithm itself is known as an Adaptive Unscented Kalman Filter. Yeah, it's a mouthful, so let's just call it an AUKF. It's the brains of the whole operation. But for it to work right, it has to be perfectly tuned. And the paper calls this manual tuning process tedious. It's complex, it takes forever, and it really depends on a human expert getting it just right. And if you don't get that tuning right, the consequences are severe. On one hand, it can cry wolf, sending out false alarms all the time, which makes ground control waste precious time and resources chasing problems that aren't even there. Or, and this is way worse, it can completely miss a real fault, a fault that could actually doom the entire mission. So let's get to the innovation, because this is where things get really cool. The researchers built this clever and elegant solution by looking past traditional engineering and finding their inspiration in the natural world. The challenge was pretty clear, right? They had to find a way to get around this tedious, unreliable manual tuning. They needed a system that could find the absolute best settings for the filter all by itself. So they turned to this amazing algorithm inspired by nature called particle swarm optimization, or PSO. The best way to picture it is like a flock of birds or a swarm of bees, all searching for food. It's a method that finds the best possible solution to a problem by having everyone work together. Here's the basic idea of how it works. Instead of just one bird searching all alone, the whole flock works as a team. Each particle, which represents a potential set of tuning parameters, explores the possibilities. It remembers its own personal best discovery, but it also knows about the best discovery found by the entire swarm. And it's this shared knowledge that lets the whole group zero in on the best spot, or, in our case, the perfect tuning for the filter, incredibly quickly and efficiently. So the theory sounds brilliant for sure, but how much of a difference does this swarm intelligence actually make when you put it to the test? Well, the results they're pretty staggering. Just look at the data from the paper. They ran a test in a high-noise scenario, and all you need to know is that a lower number is better. The old manually tuned filter, it gets an error score of 8.27. But the enhanced filter, the one tuned by the particle swarm, it gets a score of just 3.06. And what's really powerful here is when you see it visualized like this. I mean, this isn't just a small improvement. The enhanced filter, the one tuned by the swarm, is more than twice as effective at minimizing error as the old manual one. It's a huge leap forward. And this slide really shows you the real-world impacts. The paper notes that the generic filter has bigger errors, and it takes a lot longer to catch up to what's really happening after a fault is introduced. But the enhanced filter, it tracks the real wheel's performance with incredible accuracy and speed. That means it's just far, far more reliable at spotting genuine problems and spotting them fast. Okay, so let's zoom out for a second and think about what this all means for the future of space exploration. Because this isn't just some abstract academic project. It has really profound practical implications for all of us. What this research really does is show us a clear path. It takes us from a tedious, high-stakes problem to this elegant, nature-inspired solution that just produces dramatically better results. It automates a really difficult task and helps remove that potential for human error. You know, the ultimate benefit here is all about safety and efficiency. This automated approach makes our vital hardware up in orbit more robust, more reliable. And that is absolutely critical as we depend more and more on all the technology that's circling our planet. And that kind of leaves us with this one big provocative thought. In this case, researchers solved a really complex engineering problem by basically mimicking the collective intelligence of a flock of birds. It just makes you wonder, what other huge challenges could we solve if we turn to the genius of the swarm?